Okay, so Engineer Basil, please can you tell us more about your project?
Okay, actually, where you are is Dominion City Headquarters, Calabar. This is their headquarters site. Okay,
Okay,
and currently we are building a 7,000 capacity church.
okay,
Okay, and just like you've seen, the construction is ongoing, and the place
okay,
primarily is swamp. You can see,
okay,
if you check here, you can see the swamp this way. Just put your camera here, you can see the swamp water.
okay,
Yeah, so it's a swampy terrain. Please be careful. Okay,
okay,
and now if you look around, you see some of the irons coming out like this.
okay,
Though actually, I wasn't the one who did this building from the foundation.
okay,
I just took up this building from where we have the foundation beam.
okay,
All right. So what you see here is the piles. The piles that we initially done for the foundation.
okay,
So each of these you're seeing is pile, and each of the column points there are piles underneath them.
okay,
Okay, there are all piles underneath each of those columns you see. So
okay,
let's come closer. Let me take you to where you have the beams. So actually, like I said, no, come on, come on.
okay.
Yeah. So like I said
Oh,
initially,
this you see the swamp.
yeah. So this
Wow.
is this is the original terrain. You can see the
Okay,
way it is.
okay,
It's a swampy area, and just like I said, you can see the beam.
okay,
You can see all the beams. Those beams are
okay,
450 in width,
okay,
and the height is 1.2 meters.
okay,
All right. So that is how
okay,
it is for the entire area. So actually, the idea is because of how the terrain is,
okay,
we didn't want to bother to waste time doing the filling first before we continue.
okay.
So that's why I had to do it like a portal frame. When you've seen the
Like a
column,
portal frame.
yeah, I'm
Okay,
doing it. I'm building frame here.
okay,
Okay, I'm
okay,
not building solid with blocks.
okay,
So
okay,
all the blocks you're seeing, you're building them later to meet up with the columns.
okay,
Okay. So if you check there, you can see the formwork we
okay,
are currently doing
okay,
for the decking
okay,
slab.
okay,
So initially I wanted to use solid slab.
okay,
But when I now looked at the terrain and the condition of the soil,
okay,
I had to use rib.
okay.
Rib as a way of reducing, the load
Load.
on the
Okay,
foundation.
okay,
So I had to use rib so I can reduce the load on the
okay,
foundation. So all of that I'm going to be using rib floor. So when we finish here, I'm going to take you up there. I'm going to be using
okay,
polystyrene material. So if you also check here, you can see the frame columns.
okay,
We've already done the columns in place, and work is still ongoing there.
okay,
Okay. So just feel free. You can just video around.
okay,
Okay. And then here is where we have the altar.
okay,
This is where the podium is. Okay. So this is where the minister will stay.
okay,
So yeah, to minister to the people. So if you look
okay,
at this building, the length of this building is 62 meters.
okay.
It's almost 62.5 meters.
Oh, it's quite big.
Then the width is about 45.5 meters.
Okay,
Okay, and I'm going to be having a steel curved roof
okay,
on top of this. Okay,
okay,
so that is how it is. So what I'm going to do now is I'm going to take you to the top, so you can also see the beams already in place.
okay,
Though the polystyrene materials are not yet in place,
okay,
but they will be here any moment from now.
okay,
Okay, so that is that. So I think you can pause the
okay, okay.
video
We'll
first
take a
while we go up.
take a
Yeah.
walk. Okay. Now, can you explain to us
Okay,
what's
so
going on here?
if you look at the formwork, you can see them being spaced.
Okay,
If you look at them, you see the spacing for the formwork.
okay,
Now, somebody may ask, why do you have to do it this way?
okay,
Now, if you look at the economy of Nigeria today,
okay,
you cannot afford to say you want to buy all of these materials
okay,
and just put everywhere. That's one of the advantage of rip slab.
okay,
Okay, when you're using polystyrene, this is one of the advantage.
okay,
So what I'm doing now, though a lot of people will not bother about doing this, a
okay,
whole lot of people won't bother about doing this.
okay,
But why I decided to do this is you have to be on the economy side.
okay,
So the polystyrene will be in between those spaces because the width of my polystyrene is 450 mm.
okay,
Okay, so it's going to be in between there. So it's going to be sitting on 50 mm on the board this way, 50 mm on the board
okay,
the other side. Okay, and polystyrene material is strong, so they can stand on it. That
okay,
little support is okay.
okay,
So that's why you're seeing that. And that again, if you look critically on the, if you look at the wood, you can see the beams. Though we are going to climb
okay,
up, so you can see the beam clearly.
okay,
You see the beams, the rib beams on
okay,
top of it. Okay. me know.
We are up now.
Okay, so just put your camera through first.
Okay.
All right. So what you're seeing here now is just like we were talking before. If you look at, you can now see the spaces on the formwork. Please be careful.
Okay.
Be careful. You can see the space in there. You can come closer to see the rib beam. Just come closer.
Okay. What is this called?
Now, this is the rib beam, just like you've seen here.
Okay.
Okay, so you can see they are made of 12 bars.
Okay.
Okay, and you can see the nature of the stirrups.
Okay.
You can see the way the stirrups have been bent.
Okay.
This is another economical part of it. Depends on your design anyways. Okay. So that is that. So this is the primary beam. Okay.
So what can you talk about this particular design? Because you make mention that it's depending on your design.
Yeah, actually, depending on the one is the loading.
Okay.
On this building.
Okay.
That is one. Two is the spacing, the size of your polystyrene.
Okay.
That also matters a whole lot.
Okay.
So if your polystyrene size is wider,
okay,
and you're having a bigger load on this building,
okay,
you know, it's going to give you even up to 4 of this reinforcement.
Okay.
It may even give you 16 mm depending on what the case may be.
Okay.
Okay. So for my case here, I have 450 as the size of the polystyrene.
Okay.
And you know the thickness of my beam is 200. The
okay.
polystyrene thickness is 200.
Okay.
Okay. So after my analysis, this is what I had. In fact, there are some places I had 1 bar down and 1 bar up.
Okay.
You know, but I had to make it all uniform.
Okay.
So that's why you're seeing triangle, 2Y16 down, sorry, 2Y12 down,
okay,
and 1Y12 up. All of them anchoring on the primary beam.
Okay.
This is the primary beam.
Okay.
Okay, so all of them are anchoring on the primary beam. You have to anchor it on this. Okay. So this is the guy carrying the loads to the column.
Okay.
These ones are the ones collecting individual loads.
Okay.
Each of those areas.
Okay.
And transferring it directly to this guy. This guy takes it directly to the column.
Okay.
Just like you've seen them. So you can just view around, just turn your camera around. And
okay. Before I do that, you said there are sizes of polystyrene slab.
Yeah.
And you decide to use 450 for the width, then the thickness 200, then the length is your length is 300. So can you let us know other sizes of your polystyrene slab that you have?
If you're doing a roof floor, okay?
Okay.
If you're doing a roof floor, depending on the purpose of that building, I will not advise you to go beyond 600. When you're doing roof is not like solid slab.
Okay.
You know, and again, you have to put into consideration.
So rib is a lighter slab.
We will not say yes.
Okay.
You know, when you're considering it per square meter.
Okay.
You're having a lesser weight.
Okay.
Compared to a solid slab. So because when you're talking about solid slab, you know the thickness of your solid slab.
Okay.
And we are dealing with a square meter.
Okay.
So when you're talking about square meter of this rib, you won't have the load that you'll be having for your solid slab.
Okay.
Same with other slabs. So when we're talking about slab that has minimum dead load, its own self weight, that is a little minimum, is this.
Okay.
So this is the one that will give you less of self weight when you're considering self weight. So that is on one side. Then the topping I'm going to be having here is 75 mm.
Okay.
So I'm going to be using 75 mm thick slab on top of this.
Okay.
And I'm actually using mesh wire.
Okay.
Yeah, there's a specification for that.
Okay.
So that's primarily what is going to happen. So if you check, just like I enumerated before, between these points, okay, and this point is where my polystyrene is going to be. Okay. So polystyrene is going to rest here. Okay. And it's also going to be resting here. Okay. Okay. So that we now have concrete cover from here to here. Okay. The width of this beam is 200 mm. Okay. The height is 200. Okay. But if we had the thickness of the slab, that's 275. Okay. That's the whole height of the beam. Okay. So my polystyrene now, the same thing for all of the areas you're seeing here. Okay. So automatically, if you check what is happening here, I have saved money here. Okay. Okay. Because this would have taken almost 1.5 board. Okay. So I've saved money there, I've saved money there, I've saved money there. So that is another advantage of it. Okay. But that's why you need to get a good polystyrene. Okay. That can sit here without, sagging. Okay. Alright. So I think that's all for now. You can just take a view around.
Okay.
Please be careful the way you're matching.